Hi everyone! So today's lesson we're going to talk about operations with radicals. Before we get into that, we would like to visit the definition, what like radicals mean. Like radicals have the same index and same radicand. So what that means, for example, square root of 2 and 3 times square root of 2 are like radicals. Why? Because we have the same index, which is this is a square root, not a cube root and a square root. And then what's inside here, which is the radicand, is 2. They're both 2's. So in this case, we can add or subtract the following radicals. Let's look at a few examples where you can add and subtract radicals together. So we have example 5 times radical 7 plus radical 11 minus 8 square root of 7. And notice I've used different terms. I said radical 7 and then square root of 7. They mean the same thing. We're going to use the commutative property of addition. Because I know that radical 7 or square root of 7s are my like radicals or like terms, sort of say, just like how we would have 5x plus 8x, we can kind of treat that as the like terms. So what we do is 5 radical 7, I'm going to rearrange, minus 8 radical 7 plus radical 11. Commutative property of addition. Then I'm going to subtract these two, 5 and 8, and leave square root of 7, and then bring down square root of 11. We get negative 3 square root of 7 plus square root of 11. And we can't go any further, so therefore this is my final answer. Next example is 10 times square root of 5 plus square root of 20. For this example, I do not want you to assume that radicals with different radicands, so different radicands, 5 and 20 in this case, cannot be added or subtracted. Don't assume that. Always check to see whether you can simplify the radicals first, and then it may lead you to both of them becoming a like radical. So I'm going to leave that alone, and then I'm going to break the square root of 20. So I have 10 square root of 5 here, and I'm thinking about the greatest perfect square factor. So 4 times 5 is 20. And I know 4 is a perfect square. So let's reduce that. 10 square root of 5. And we learned this yesterday that we can break that. But you know square root of 4 is 2. And then the 5 remains inside. So if you want to recap yesterday's lesson, this is the same thing as square root of 4 times square root of 5. That becomes 2. And then square root of 5 remains inside. Next, now that we have like radicals, my radicands are the same, we can combine. So let's simplify. 10 plus 2 is 12, and then you leave the square root of 5. This question, you have 6 times cube root of x plus 2 times cube root of x. We do have the like radicals here because my radicands and my index are the same. So all you need to do is combine 6 and 2 and then leave the cube root of x, which is 8 cube root of x. Done. When multiplying radicals, you do not need like radicals. For example, for this one, when you simplify this, square root of 5 and times square root of 3 minus square root of 75, all of them are non-like radicals. The radicands are 5, 3, and 75. But because we're multiplying, it does not matter. So I'm just going to distribute, and I'm going to show you two different ways. So this is the first way. I'm going to distribute square root of 5. It becomes square root of 15. So you are keeping the radical, multiplying the inside, and then square root of 5 times square root of 75. That's the negative sign still stays, or subtraction sign stays, becomes 375. Now we're not done because it says to simplify. So we have to make sure we go steps further. Can't do much for square root of 15. We could do something to break that apart. I'm going to, again, think about the greatest perfect square factor. So we know that I'm going to try different numbers. You can try 5, you can try, different factors here, but I know that I need to take the greatest perfect square factor. So I know 25 times 15 is 375. Then, without breaking this apart, you can skip that step, or you can write it if you want to. I know that square root of 25 is a 5, and then the 15 remains the same. Your goal here is to simplify, which means I need to figure out a way to make these two like terms, basically, like radicals. So there is a 1 in the front. Make sure you remember that. So we have 1 minus 5, and then the square root of 15 stays. So -4 square root of 15 is my final answer for this question. Let me show you the second way. The second method goes something like this. Instead of distributing the square root of 5, we're going to kind of break this apart so that it becomes square root of 3 is a like radical. So rewrite square root of 5 on the outside. And then on the inside, leave the square root of 3 because you can't do much there. This is already in the simplest form. But 75, what can you break into so that you can take out? Or what can you break, or how can you break 72 or square root of 75, into so that it becomes a like radical to square root of 3? I know that 5 times 5 is 25. That's a perfect square. So inside my radical, I have 25 times 3, right? 3/4 becomes 75 cents. So that could be your perfect segue in order to simplify this. So square root of 5. Then I'm just rewriting the steps that I don't do. That's square root of 25 is 5, perfect square. And then the 3 remains. I can simplify the inside first, inside the parentheses first. So square root of 5 times, this is a 1 in the front. So 1 minus 5 is -4, square root of 3. And then we can multiply. This is multiplication. So -4, square root of 15. And that's it. Just another point here. When you multiply the radicals, the outside number gets multiplied with the outside number, which is 1 and -4, becomes -4. And then the radicals multiply with each other.